Imagine that you are back home after a long day, but no electricity to power your light. Imagine that you have no house to live in because of the flooding or fire. Or even imagine that you live in a place in 36 degrees C almost every day. Yes, our world is in energy crisis. We can tell the flood-stricken and fire disaster in many places. We can feel the extreme heat and really miss the old days when we only need a small fan for cooling in summer. The Intergovernmental Panel on Climate Change said that our planet is warming even faster than we thought. And they said that the carbon emissions need to be cut in half by 2030 and towards net zero emissions by 2050. What we can do to catch up with this tendency? So I'm here today on behalf of our research team to give you a progress report on our breakthrough. As we know that 71% of our Earth is covered by water. How about we just drop some water to generate electricity? Sounds so crazy. Is that possible? You may ask. It took our Mother Nature 540 million years of revolution to develop. Trees work in a way that water is absorbed from the roots, travels via the xylem, and then evaporates through the leaves. Inspired by water travel system in trees, our team, Meng Yaogao, Jie Yuyang, Wei-Ting Chen, leading by Professor Li Xianye from Department of Chemical Engineering, National Taiwan University of Science and Technology, has started these crazy tasks. At the beginning, it was not obvious. We tried papers, cottons, but it was no response. We then think about coating some functional materials on this substrate. And it works. That's so crazy. Then the optimization of this membrane became our tasks. We tried different amounts of the drop-in water, directional effects, different salt solutions, geometry effects, including trapezoid and rectangle. We also tried the coating materials, including one-dimensional, two-dimensional materials, and beyond, as well as the assembling configurations of the membrane. After 2 years of hard working, now I'm ready to show you our breakthrough here. It is a bendable, water-enabled portable power box. We name it BWPPB for short. This is a layer-by-layer structure with the two-dimensional materials in the top and bottom side, and the polyelectrolytes with space charges in the middle. In addition, the two-dimensional materials on the top side could act as a roof to protect the drop-in water from evaporation. Then the retention time has been elongated. Moreover, this layer-by-layer structure could foster the ion transportation. By dropping water on one side, the counter ions will flow within the drop-in water. And under the capillary flow and evaporation, there will form a potential difference at the wet and dry interface. Then the power generated. Now we can see that only one piece of membrane can achieve 0.8 volts of the voltage and 80 microampere of this current. This is a high performance for this tiny membrane. And we can see that we can generate a power immediately at the water dropped point. Moreover, by adjusting different water solutions, it can achieve more than 1 day power output. In addition, the power can keep stable at different bending angles. We picked up some water from the northern coast in Taiwan, and 3 drops of this seawater can achieve a 0.6 volt and 25 microampere of the current. when we use the BWPPB in series and parallel connections. It can power our commercial calculator as well as different colors of the LED. Now you can understand that this is really a high-performance breakthrough. But how about the weight? Is that so heavy, you may ask? Let me show you that one piece of the BWPPB is only 0.176 gram, just as light as a piece of tissue. In consequence, we achieved a bright device with the properties of bendability and reusability. And we can also get the power immediately when we drop water on it. This is a green, high-performance and time-lasting power generator. For this technology, we have applied the patents from Taiwan and the US. Now, the face masks has become a powerful tool for us against the COVID-19. We then think about combine the BWPPB with masks. And the results has shown that it keeps stable during our normal breath. We are trying to cooperate with experts in biomedical engineering to implant biosensors to detect more viruses and toxins. You can also bring with you when you go camping. It will light your camping night by dropping some water or urine. That's so interesting. You can also incorporate the BWPPB into wearable devices and clothes. From 0 to 1 is hard. The real challenge is from 1 to 10 and far beyond. Our research team is still working hard on this technology, and there is still a lot to learn. We even think towards carbon negative. During my research, I keep thinking of my 2 daughters and the world they will live in the future. Significant work is needed to reduce the greenhouse gas emissions and increase the development of renewable energy. Without urgent action, the climate change will affect our ability to achieve the 17 Sustainable Development Goals. So now it's the time for us to work together to achieve a sustainable environment for our next generation and for the world. Thank you.